Hi, everyone. We're going to be going over this progress check review. Feel free to fast forward it to the point where you need more help, but make sure you check your answers either way. Okay, so the first page was we're going over all the different types of graphs that we have been working on this quarter and all the characteristics that go along with them that we've talked about as we went. So the first one is a square root function. And remember, you get the endpoint by looking at the translations here. So this is right 3 and up 5. So my point is 3, 5. So there's my point right there. Okay, and then you have the points 0, 0, 1, 1, 4, 2 are your original parent function points. So when I've moved this right 3 up 5, I can go right from this point as like my new 0, 0. I go 1, 1, and then 1, 2, 3, 4, 2. And so there are my points, and there's my graph. Okay, so here's my graph. My domain is my x values, read from left to right. So I'm starting here and going to the right. So I'm starting at 3 to infinity. So that's my domain. My range is my y values. So I'm starting at my y value here. Again, this is the point 3, 5. So my y value here is 5. So I'm going from 5 and it's going up from there. So it's 5 to infinity. For the increasing interval, it's increasing the entire time. So we say that it increases along the domain. So it is increasing along the domain of 3 to infinity, but we don't need the bracket here because we're just saying it's starting at 3 and going to go from there. Okay, your decreasing interval, you're reading from left to right, so it never decreases. As x goes to negative infinity, again, that means as you go left. So this one is left, negative infinity for x is going to the left. So as x goes to negative infinity, well, the graph doesn't go to negative infinity. That's why I wrote NA here. It does not go to negative infinity. Okay, so this one means as you go right, what is the graph doing? Well, as you go to the right, the graph is going up. So we're going to go to infinity. Okay, the rate of the change from the interval x equals 4 to x equals 7. So I have here x equals 4. I can plug it in here and get the answer. But you can actually look at the points here. So at x equals, I just want to show you how to plug it in. Okay, so at x equals 1, no, I'm sorry, x equals 4, you're going to plug it into the equation. So you're going to do f of 4, basically plug it in, and you're going to get square root of 4 minus 3 and then plus 5. Well, that is 1. So the square root of 1 is still 1. 1 plus 5 is 6. Okay, then x equals 7. And again, you can see it's 4, 6. And then at 7, you can see that the answer should be 7. But again, I'm going to show you how to plug it in. So I'm going to do f of 7 and plug that in. So I get square root of 7 minus 3 plus 5. So 7 minus 3 is 4. Square root of that is 2. 2 plus 5 equals 7. So then you're going to do basically the slope formula. So this is like slope. You're taking f of b minus f of a over b minus a. So you're taking y2 minus y1 over x2 minus x1. So here's your y's and here's your x's. So 7 minus 6 over 7 minus 4. So you get 1/3. That's your rate of change. Let me rewrite this for you. Okay, so it's like slope. It's like this, y2 minus y1 over x2 minus x1. So I'm going to be putting that in, and I'm going to get 7 minus 6. That's my set y's over 7 minus 4 equals 1/3. That's my rate of change. That's my answer to that. Okay, so all that work goes with this last problem here. Okay, type of function for this. It is a squared function. We call that a quadratic, and it makes a parabola when you graph it. Your key points for this is a 0, 0, but it's in the middle. So I have -1, 1, and -2, 4. Then I have 1, 1, and 2, 4. So it's symmetric over the y-axis when it's the normal parent function. All right, so your endpoint, again, you get, it's not an endpoint in this case, it's called a vertex, but it's your key point. You're going to go right 5 up 3, so your point is 5, 3. So I'm going to go 5, 3, and that's my new 0, 0. So from there, I'm going to go 1, 1, and 2, 4. Okay, so you can see that those are the points as if that were counting from here being 0, 0, because the whole graph is moved right 5 and up 3. And then you're going to do it on the other side as well, so you make it symmetric, and you can figure out where those points are. Okay, so there's your quadratic. Your domain for any quadratic is all real numbers. So it's negative infinity to infinity, okay? Or all reals. Say or all real numbers. That's a symbol for all real numbers. Your range is your y values. Now this does not keep going down. So your lowest to the highest, the lowest y value is this point right here. So that is the 0.53. Make sure you're using the y value, which is 3 to infinity. Okay, this one has both an increasing interval and a decreasing interval. You read it from left to right. So it starts off decreasing first, and then it goes to increasing. So where does it start increasing? It starts increasing, remember, and you're looking at reading from left to right, so you're using x values. So from 5 to infinity. That's your answer, 5 to infinity. And then decreasing is this left side of the graph, and it's actually going to start all the way over here somewhere and decrease, right? All the way up here and decrease. So it's from negative infinity. It's going to keep going to the left, negative infinity, up until 5. You can also write x is less than 5, and this one is x is greater than 5. You can do that also. As x goes to negative infinity, that means as you go to the left, again, this is left. As the graph goes to the left, the graph, what are the y values doing? F of x just means your y value. So what is y doing? It's going up. We say it goes to infinity. Okay, so this one means as you go to the right. And as I go to the right, the graph is, the y values are still going up. So that's also infinity. Is this one-to-one? One-to-one means it passes the horizontal line test. If I draw a horizontal line here, you can see that it hits more than 1 point. It does not pass the horizontal line test, so it is not one-to-one. Doesn't pass horizontal line test. Okay. Next one, it is a cube root function. If you remember, the points for cube root was you had one side of it, you had a point of symmetry at 0, 0, and then you had 1, 1 again, and then 8, 2. And then you're going to go the other way also, but it's -1, -1, and -8, -2. Smush this all in here. Okay, so here's your points. And again, you do have a calculator. You can put it in the calculator and get your actual points by putting in -2 and then find the cube root on there. You can also use the 1/3 exponent for cube root and then do -5. Okay, this one again is not called an endpoint, it's called a point of symmetry, so I fixed that. And again, you get it from inside this and then the outside, so your translation. So it hasn't moved right or left. This -5 is not inside the radical, so it has moved down 5. So this graph just has an endpoint here of being moved down 5. 1, 2, 3, 4, 5, yeah. Okay, so 0, -5 is my point of symmetry. The nice thing about cubes and cube roots is that both answers here are all real numbers. It's going to keep going left. It's going to keep going right. So that's my domain, all real numbers. It's going to keep going down. It's going to keep going up. And it doesn't matter which way it's going. It's just you're looking at up and down and right or left. For the domain is right or left. The range is up and down. So increasing interval. Again, don't look at the graph in pieces. You want to go from the left side to the right side. So if you go from left to right, it's on this side, and I'm going to go like this, decreasing, decreasing, decreasing the entire time. So that is decreasing. You're going to write the domain of infinity to infinity. Increasing, you're going to write NA. All right, so as x goes to negative infinity, what is the graph doing? On the left side, the graph is going up, so we write infinity. On the right side, the graph is going down, so we write negative infinity. Is the graph one-to-one? Yeah, I'm going to draw a horizontal line anywhere. It's only going to hit one time. So yes, passes horizontal line test. All right, this one, it has a negative in front of the x. That means it's going to be reflected over the y-axis. But then we're going to take that negative out, and it's going to actually be x minus 2. So this means it's gone right 2 and down 2. So right 2 and down 2 is my key point right there. It is square root, so I only have to do those 3 key points. Okay, so I'm going to go from here, and it's been reflected over the y-axis. So instead of going this way, it's going to go that way. So I'm going to go left 1, up 1, and oh wait, I don't think I drew that correctly on there. Let me fix that. Okay, so I would have gone right 2, down 2 originally. It's right there. And then I'm going to go left 1, up 1. And I'm going to go 1, 2, 3, 4, and then 1, 2. Okay, so here's my graph. Okay, so my endpoint is 2, -2. My domain, again, left to right. So it starts over here, so it's negative infinity. Again, try not to look at the arrows. If you want to just continue to the end of the page, that means it's going to keep going. So it keeps going this way, so it's negative infinity. And then it stops here at this value. Remember, this is 2, negative 2. So my x value here is 2, and it's included, so we write a bracket. My range is the lowest to the highest. So my lowest y value is right here at negative 2. And then even though it's going to the left, you're looking at up and down. It's going to keep going up. So it goes to infinity. All right, is this increasing? Again, left to right, it goes down. So I'm going to write NA for increasing because it's decreasing. So decreasing from the domain, negative infinity to negative, to 2. All right, so as I go to the left, it's going up. So it's going to go to infinity. As I go to the right, it doesn't keep going. So I'm going to write NA. So it does not keep going right. Okay. So is it 1 to 1? Yes, I draw a horizontal line somewhere. It's just going to pass one time. So it is 1 to 1. Okay, so what type of function is this? It is an exponential function. This one we did more recently. Remember here, it is a negative x. So my actual function is 4 times, flip this over to make the x positive, 2 plus 1. Okay, it is an exponential. My y-intercept, again, my y-intercept is here. I've moved my whole graph up 1. So my normal asymptote is usually at y equals 0, but I'm moving it up 1. So my new asymptote is y equals 1. Asymptote y equals 1. Okay, so again, normally my y-intercept would be at 4, but I moved the whole graph up 1. So I'm going to go 4 from this asymptote, 1, 2, 3, 4, and I'm actually at 5. Okay, so 0, 5. Okay, so again, you can still count the points from your asymptote by using the multiplier. So I'm 4 from my asymptote. My multiplier is 2. So I'm going to multiply that by 2 for the next one. So I'm going to be 8 from the asymptote. So I'm actually going to be 1, 2, 3, 4, 5, 6, 7, 8. So I'm actually going to be at 9 because I moved the whole graph up 1. So here, if I'm going this way, I'm going to divide by 2. So I'm going to be 2 away from the asymptote. Here. And then I'm going to be 1 away from the asymptote if I divide by 2 again. And so you can see it's getting closer and closer and closer to this asymptote. I'm going to come around like this and keep going that way. Okay, again, domain is all real numbers, so negative infinity to infinity keeps going. Range does not keep going down, so we're going to start at the lowest value, which is 1. At 1 is not included because there's an asymptote there. It's never going to touch that. And then it keeps going up to infinity. All right, it is increasing the entire time. And so we're going to write the domain again, negative infinity to infinity. And it is not decreasing, so I'm going to put an NA here as we go to the left. So as I go to the left here, it is never going to get to this number here, but it's going to get closer and closer and closer to this asymptote. So it's going to get closer and closer and closer to 1. Okay. As I go to the right, though, it's going up, so it's going to go to infinity. So this is actually growth. If you look at the original equation, please simplify this negative exponent, because sometimes it makes it, you just look at the negative exponent and say, oh, it's decay. No, you want to look at this b value once it's simplified. So this negative exponent means that I have flipped this b value over, and it is now a 2 over 1 instead of 1 over 2. And so this is up here. So this is going to have a b value of 2, and it is growth. And you can look at the graph once you graph it also, it's growth. Find the rate of change on the interval -1 to 1. So again, I'm going to do x is -1, so I'm going to do f of -1 and plug it in. So I'm going to do 4 times 2 to the -1 plus 1. All right, 4 times 2 to the -1, that means I flip this over and it's going to be 1/2. So 4 times 1/2 is 2. So that's 2 plus 1 equals 3. And again, if you have calculators, you can go to the table on your calculator and just look at the -1 value, it should say 3. And then you just look at, well, you also have a graph here, -1 is 3. And you look at the 1 value and it should be 9, but I'm going to show you how to plug it in. So I'm going to do F, because you might not have the graph for yourself. You're going to have to either look at your calculator or you're going to have to plug it into the equation. So F of 1, when I put it in, is 4 times 2 to the 1 plus 1. Well, that's just 2. 2 to the 1 is 2. Times 4 is 8, plus 1 is 9. So 8 plus 1 equals 9. All right, so you're not done. You got to get these values, these y values for these x values. Okay, so you're going to do y2 minus y1. So that is 9 minus 3 over 1 minus -1. So 1 minus a -1. So that is 6 over 2, which equals a rate of change of 3. Okay, type of function. This is also an exponential function. This is that e. If you remember, e is approximately 2.718. And if you want to plug that number in instead of having the e there to see what it looks like, that's fine. But your y-intercept, notice the asymptote again is up 1. So I'm going to draw my asymptote here. My graph has moved up 1. This last number here, this plus or minus, is basically going to tell you what your asymptote is. That is your vertical translation. So it's tell you how far the graph moved up and down. So that is going to be your asymptote at y equals 1. And then my y-intercept is normally at 2, but it has gone 2 from the asymptote. So it's actually going to be at 3. Okay, so for this, you can go to your calculator and get more points, but I don't expect you to get exponents of 2.718 and figure that out in your head. So if you just get this one key point, you should also know that this is going to be growth because the b value equals 2.718, which is greater than 1. Okay, if it's greater than 1, it's growth. If it's less than 1, a fraction that's less than 1, then it's going to be decay. So here's your basic shape of the graph. Okay, so make sure you have at least the one key point if you don't have a calculator. All right, your y-intercept is going to be normal 2 plus 1 is 3, so 0, 3. Your domain, again, always the same answer, all real numbers for exponential. And your range is your y value, so it's again 1 to infinity, but not including the 1. It increases along your entire domain, so we increase from -infinity to infinity. It is not decreasing at all, so I'm going to write NA. As I go to the left, the graph goes to 1. I wish I should have picked a different asymptote here. We go to 1. As we go to the right, the graph goes up, so it goes to infinity. Okay, so that's all the graphing. Okay, so now let's move on to the next part, which was inverses. When you're doing an inverse, remember we did this little table. You can just look at basically what would be your solving steps. So I'm going to be looking at, normally I would be squaring the function, then multiplying it by 5/3, and then subtracting 2. So remember, we go down this way when we're doing the original operations, and we go up this way when we're doing the inverse operations. So let me just do this from the beginning with you. So let me erase this and explain where this answer came from. Okay, so I'm going to start with x. I always have to start with an x. Okay, so x, and then I'm going to do plus 2 first. And then we'll take that whole thing times 3 over 5. That is the inverse of times 5 over 3. You multiply by the reciprocal to get rid of the fraction. And then you're going to square root that whole thing. Okay, so whenever you're doing the next step, it has to be done to the whole thing. That's why we put a parentheses around the x plus 2, then times 5/3, and then square root the whole thing. So that is your inverse function. Okay, so for this one, I'm going to go from the outside to the inside. So I'm going to do -1. I can do this without doing the table once you get good at it. But I'm going to just do this like this. Start with an x and get rid of the furthest thing away here. So I'm going to do -1. If you were solving this, you do -1, and then you take that answer, try that one more time, because it's going to be divided by 2. So I'm going to do x -1, take that answer and divide that by 2. I want to get rid of that next, get rid of this first, -1, divide that by 2, and then I'm going to get rid of that by taking the cube root. Okay, so that goes away by taking the cube root. And then at the very end, you're going to have to get rid of this -5, so it becomes +5 after the cube root. Okay, so that is the inverse on that one. The restriction part is you're only going to get restrictions of the graphs that we've done so far. The only one that has a restriction is this quadratic, because remember, we couldn't do the inverse. The inverse would look like a sideways parabola, and it wouldn't pass the vertical line test. So we checked it by using the horizontal line test. The only one that doesn't pass is the squared function, which is a parabola. It's a quadratic. So whenever you see a squared, you're going to have a restriction on the domain. Okay, so as you just want to take the right side of the parabola, so you find your vertex and go to the right, so it's x is greater than or equal to 0. This one, there's no restrictions on the domain. Okay, if I want some points on the inverse, you can do that 2 ways. You can put this and find some points on here, or you could find some points on here and switch the x and y's. Okay, I don't have that in front of me, so I will put that into the answer key when I'm done. Do I have any points here? So I know a point on my inverse on this one is going to be negative 2, 0. At least I know that one. Okay, so negative 2, 0 is going to be my endpoint. So I would go negative 1, 1, I think. I'm going to come back to that. Okay. Let me do the inverses of this one also. And there's no restrictions on this, no restrictions on this. Here you'll get another restriction because you are going to have a parabola again. Okay, so if you notice on this one, this has gone right 2 and down 3. So when I go right 2, down 3, my endpoint is 2, negative 3. Your restriction is on the x value. So all the ones to the right of this vertex is x is greater than or equal to 2. All right, so this one, my inverse, I'm going to first get rid of this minus 7 by doing plus 7. So I'm going to do x plus 7. Okay, then I'm going to get rid of this 1/2. That's the opposite of that is times 2. So I'm going to take that answer and times 2, like that. And then I'm going to get rid of this square root by squaring. So I've got to square the whole thing. So I have a double parentheses here, squared. And then I get rid of this minus 1 by doing plus 1. So again, if you wanted to do this little table, this O, I. If I look at my original values, first I did minus 1, and then I took the square root of that, and then I did times 1/2. Times 1/2 is the same thing as divide by 2, and then a minus 7. So we're going to first do plus 7, and then to get rid of times 1/2, I'm going to times by 2 over 1, so just 2. And the opposite of square root is square, and then minus 1 is plus 1. So I did plus 7 first, then times 2, then squared, and then plus 1. Okay, so there's no restrictions on the domain. And again, check back to the answer key. I'll put some points on the inverse. But all you're doing is finding some points on the original and flipping them, or if you want to use the inverse function, finding some points for x and getting the y. Okay? So same thing on this one. Well, I know my endpoint here is 2, negative 3, so I know negative 3, 2 at least is going to be on my inverse. This one is 5, 1, so I know 1, 5 is going to be my inverse. This one is 1, 7, 1, negative 7, so I know negative 7, 1 is going to be my inverse. And I'll go back and fill in some more points there to make sure you got the right answer. Okay. All right, the first 2 of these are done for you because I did it in your groups that you were in. So again, you're just solving, and then you check for extraneous solutions. And your extraneous solutions are only going to be where you have a square root in your problem, and you're going to look for if you get an extraneous solution in that problem, because you can't take the square root of a negative number. All right, so here you just do plus 5, get an answer, you got 16. And to get rid of the 4th power, you're going to do the 4th root. And since I didn't tell you how to put that in your calculator, you can also do it to the 1/4 power. Just make sure when you take the 1/4 power, you have that in parentheses in your calculators. All right, so the 1/4 power of 16 is 2. So then we have this left over. We do minus 1, we get 1. Then we do divide by 3, you get x equals 1/3 is your final answer. Okay, so for this one, I get negative 7, minus 7, minus 7, I get 15. And then I do negative 3. I'm dividing this by negative 3. I need to go from the outside back in. I'm going to cancel out the negative 3's next. I get negative 5. Right here, I can tell you that this is not going to give me a real solution. I can go through the whole process and get an answer and then check it. But right here, I'm going to say that I have a square root of something and I'm getting a negative number. That's not going to work. So this is actually going to give you no real solution. This is going to be no real solution. Okay, so if I want to keep going here, the next step is to square. I get 25 equals 2x. I'm going to divide by 2, I get x equals 12.5. Now, if you take 12.5 and put it back in here, it is not going to work to give you 22 on this side. So if you want to go back and check it, you can, and that's not a real solution. It is extraneous. So you can write that as extraneous, or you can just write no real solution. Let me do it with the checking way. So if I have a little check over here, if I plug this in, 22, I'm trying to check, does that equal 7 minus 3 and then square root of 2 times 12.5? Okay, so that is 25. So 7 minus 3 square root of 25. And then that's 7 minus 3 times 5, and that's 7 minus 15, which is not 22. So you say that this does not equal 22. 3 times 5 is 15. 7 minus 15, it is not 22. That's why this answer is the answer that you got, but it is extraneous. All right, so let's go ahead and solve this. I have plus 4 plus 4. I get negative 8 equals negative square root of x plus 1. Now this one is different because I still have this negative here, whereas on this one I had just square root of 2x equals negative 5. This one I have negative square root. So I'm going to get rid of this negative first before I decide if it's going to be extraneous or not. So I can divide by negative 1, and that'll cancel that out. Divide this by negative 1, and I get a positive 8 over here. So look here. I have square root of x plus 1. I have the square root isolated. Square root of something can give me 8. So you want to be able to keep solving this. So to get rid of the square root, I'm going to square. I get 64 equals x plus 1. And I'm going to do minus 1, minus 1. I get 63 equals x. Okay, last one. Cube root is defined for all real numbers, so you don't have to worry about any extraneous. So I'm going to divide by 4 first. To get rid of that 4, I get cube root of x minus 5 equals 5. Divide by 4 again. And then I'm going to cube both sides. I get 125 here equals x minus 5. Then I do plus 5 plus 5. I get x equals 130. My final answer. Okay. Okay, so these are the word problems we just did last week. All right, so you want to be able to find 2 points on these unless it's given to you what your starting value is and what you're multiplying by. Notice it gives you your starting value. It's starting with 15. That's your starting value, 0, 15, but it does not give you what you're multiplying by. So you need to do this y equals ab to the x thing to figure out what you're multiplying by in this one. All right, so after 8 years, the group of deer is growing exponentially to 2,879 deer. So that is going to be your other point. So you're going to do this y equals ab to the x on both of them and figure out what your b value is. You already have a. A is 15. Let me write that down. That is your a value. Okay, so here I just need to find out what my b value is. So I'm going to divide this. Here's my calculator. Okay, so I have 2,879 divided by 15, and I get 191.933. All right, so again, I get 2,879. Yep, 191.933. Okay, so equals, and I'm going to subtract this, and I get it b to the 8th. All right, so to get rid of this, I'm going to take it to the 1/8 power. I'm going to take this, so to the 1/8 power. All right, so when I take this to the 1/8 power, let me try that again. I should have my answers up. Exponent, parentheses, 1/8, 2.706. Okay, so that's 3 decimal places. 2.706 is my b value. So my final answer, putting the x in, putting the a and b here. So y equals 15 is my a, parentheses 2.706 to the t, or x. I'm going to use t here because it's time after t years. All right, so find the average rate of change. I'm going to put in between 0 and 3. Well, I already know the 0 is 15. That's my start. So I'm going to plug this 3 in here to figure this out. So I'm going to do 15. I'm going to do 15 times 2.706 to the 3 and see what we get. So I'm going to just put that right in my calculator. 15 parentheses 2.706 parentheses exponent 3. And I get an answer of 297.2. Oh, it says 3 decimal places. So 297.2 is fine for this because my final answer, I'm going to use 3 decimal places. So I'm going to do this whole rate of change thing again, y2 minus y1 over x2 minus x1. So here are your y values. You do 297.2 minus 15 over my x values, which is 3 and 0. So 3 minus 0. So I'm going to take this answer minus 15, and I get 282.2 divided by 3. And my final answer is 94.073. 94.073. And if you would have put 0.072, that would have been okay also. Okay, so this one, you have, again, starting value and what's going to happen after whatever years. Now, I saw when looking at some of your homework assignments that you did 220, 45 million, and then 2030, and you had 108 million. You can just do this. Your starting value is what you're starting with here at 45, but if you use how much time has gone by, in 2030, it's 10 years that have gone by, and it's 108 million. Okay, so you have to do this y equals ab to the x again. So you're doing 108 equals AB to the 10th, and then 45 equals AB to the 0. Okay, remember your A value is already given, so you're just solving for B. So you do 108 divided by 45. So you get 2.4. A's cancel out, subtract that, and you get B to the 10th. So you're going to take 2.4 to the exponent of 1/10. So 2.4 exponent parentheses 1 divided by 10. And I get 1.091. Let's do this. So y equals A, which was 45. And you can just say that this answer is in millions because these are both in millions. So times 1.091 to the x or to the t, if you're going to write it as a exponential model. So in 2060, how many zombies will be there? So this is, again, you want to use t as a lapse time. So after 2020, how much time has gone by? So 2060 to 2020 is my start of 2020 to 2060. That's 40 years. So here t equals 40 years. Okay, so I'm going to put in 40 into my model. So y equals 45 times 1.091 to the 40th power. So I'm going to put that right in my calculator. 45 parentheses 1.091 parentheses exponent 40. 1,466. And this is zombie, so we're going to round it to the nearest zombie. So 1,466 is when you round it. Okay, zombies. Okay, so here's another one. This one's telling you what your multiplier is, so you don't have to actually do this whole 2 points thing. So it's starting with 12 people. So my A is 12. And then it's doubling. That's telling you what you're multiplying by. When you're doubling, your B value is going to be 2, okay, every 3 days. So when you want to show every 3 days, you're going to divide it by 3 for your exponent. So here, you're going to have y equals, or you want to do a virus, let's call it V. The virus starts with 12 people, and it's going to double. And normally you just put an exponent t there, but you're saying only every 3 days, so it's t over 3. Okay, so how many people will have the virus after 30 days? So you're going to do virus people equals 12, and then times 2, and then 30 over 3, which is 10. So you're doing 12 times 2 to the 10th power. Okay, so we'll put this in 12 parentheses 2 exponent 10. And you have 12,288. Okay. All right, so these are the your ones with the interest, and you had 2 formulas. You had the compound interest, and you also had the PERT, okay, the continuous. So notice this one right here says continuous. This is continuous goes to PERT. So let's write that over here. A equals PE to the RT power. Okay, so that is your PERT formula. That's for compounding continuously. This one is for compounding just compound interest. And it says weekly, so that tells you, again, how many times it's compounded per year. So weekly means n is 52, sorry. That means n equals 52. So you're putting the numbers into this formula. So you're starting with 2,000. That's your initial value. That always goes up front. Parentheses 1 plus r. Now, r is your interest rate. It's 4.5%. So r equals 4.5%, but you don't put in a percentage into the problem. You have to make it into a decimal. So 0.045 on that one. For this one, r equals 4%. So I'm going to make it 0.04. Again, move it over 2 spaces. So it's right here, move it 2 spaces, you get 0.04. Okay, so that way I have the formulas in here for each of them by plugging in the numbers. All right, so which fund will result in greater interest, greater earnings over 10 years, Fund A or Fund B? So let's do Fund A, and I'm going to just put the numbers in. And 10 years, 2,000, parentheses 1 plus 0.045 over 52. And then to the 52 times 10. And either keep that in parentheses in your calculator, or you can actually get the answer. That's just 520. Okay, so I'm going to put that in my calculator. 2,000 parentheses 1 plus 0.045 divided by 52 parentheses exponent 520. So my answer is 3,136. Okay, that is 0.01. I'm going with money. Okay, and then Fund B, this is for Fund A. So for Fund B, I'm going to do the PERT formula. P, and what did I put P in? 2,000 is my P value, so I'm going to put that in. So 2,000, and then E in your calculator is second ln. You can put in 2.718 if you can't find the ln button. So 2,000 E to the R, which is 0.04, times T, which is 10. Okay? All right, so I'm going to do 2,000. And again, my button for E is second ln. It comes up with the E, and the exponent is already in there, so you can do 0.04 times 10 and enter 2,983. Something went wrong there. 2,000 to 0.04 times 10. That's right. So $2,983.64. 65 cents if I rounded correctly. Okay, I'm going to have to check this. And again, see if I put the numbers in my calculator correctly, but I want to spend time on the video doing it. But I will come back and again, make sure this is correct when you actually check your final answer on the work. Okay, because I'll fix it if it's wrong. All right, we did a few of these with the class in the group that was supposed to do this. This is also not too long ago. Again, you have to have the same base to be able to combine this. So you make this the same base of 2, multiply to simplify, power to a power, I get 6x. And then you have 2 to the 6x and 2 to the negative 4. They're the same base. Leave the base alone and combine the exponents by adding. So 6x plus negative 4x is 2x. Same idea on this one. You have 9 and a 3 as your bases. You cannot combine them all together unless they're the same, but you can make them the same by making the 9 into a 3. Notice the 9 is going to be changed into a 3 to the second power. This 6x is still there. Now I'm going to combine those two or simplify this expression by taking power to a power rule, which is multiply, and I get 12x. And this one's already 3x, 3 to something, so we can leave that one alone for all these steps. So now I have the same base, and I'm going to get my simplified answer for when you are dividing, you're going to subtract the exponent. So 12x minus 5x, I'm going to get 7x. All right, for this one, I have to convert these into exponential form. So remember, it's this number over this number. So x to the 2 over 3 times x, and that's a 1, so 1 over 4. All right, here we are multiplying, so I'm going to add the exponents. So I'm going to get, I'll write out what I'm doing, x to the 2/3 plus 1/4. All right, you have to add your exponents. You have to know how to do that. You need a common denominator. So that's going to be a common denominator of 12. So x to something over 12 plus something over 12. Okay, so I'm going to multiply this one by 4. So multiply that by 4 and I get 8. Multiply this by 3, multiply that by 3 also, and I get 3. So I get x to the 8 plus 3 is 11 over 12. That's your answer on that one. This one's already done for you. You simplify the top, you get a to the 5th. You simplify the bottom, you get a to the 8th. You can simplify the inside. Since they're all a's, you can simplify that first and then take that to the 1/2 power. Or you could take both of these to the 1/2 power and then subtract. I'm going to work with this because my numbers are still not fractions yet. They're whole numbers here. So I'm going to do 5 minus 8, and I get -3. And now I'm going to multiply these two. I get -3 over 2. And then when you can't leave a negative exponent, so you get 1 over a to the positive 3 over 2 is your final answer. Okay, for this one, you have an expression inside of an expression. So that's y to the 1 over 2, 1/2. And you're going to take that whole thing and take that to the cube root, which is 1 over 3. So I'm taking that in parentheses to the 1 over 3 power. You're multiplying fractions. You go straight across. You get 1 over 6. All right, let's rewrite this one. This one is b to the 1/3. It's no radical in that one. So I'm going to flip this to no radical to a rational exponent. So that's 2 over 5. I'm dividing, so I'm going to subtract. So I'm going to get b to the 1 over 3 minus 2 over 5. All right, common denominator, b, and that's going to be 15 minus 15. All right, so that multiplies by 5 to get to 15. So 5 times 1 is 5. This multiplies by 3, so 3 times 2 is 6. So I'm going to get b to the -1 over 15, which again equals 1 over b to the positive 1 over 15. Okay, and this one is already done. Again, distribute this 3 to both of those, and then when you're dividing, so you subtract exponents, and then this negative exponent comes back to the bottom, and this is your final answer, x to the 5th over y. This one, I know a lot of you will want to just add the exponents, but you are adding here. You add the exponents when you are multiplying. When you're adding, you can only add if they're exactly the same. These are not exactly the same. So this one cannot be done. It's already simplified. You don't add the exponents here. Okay, so that's it. So that's the whole review. I'm hoping you guys will study and come with questions to the Wednesday check-in. And I'll fill in the couple that I have over here, like this one. I want to check it because it does not look right, as well as fill in the more points on this one. So come back and check your actual answer key if that's correct. But I will post this video as is for now.